Have you ever just stopped and wondered, what is all this stuff really made of? If you could just keep zooming in, past your skin, past the cells, past the molecules, what would you actually find at the very bottom? Well,
It sounds like such a simple question, right? But the answer? Ugh, the answer is absolutely mind-bending. So let's go on a little journey together. We're going to peel back the layers of reality, one tiny particle at a time, to get to the absolute core of what makes up, well, everything.
Okay, so our journey starts with something you probably remember from science class, the atom. For a really long time, scientists thought this was it, the smallest, most fundamental thing. It's our first stop on this tour, but believe me, it is definitely not our last.
so a quick refresher. Right at the heart of every single atom, you've got this super dense little core called the nucleus. And then, zipping all around that nucleus, you have these tiny, negatively charged particles called electrons. Simple enough, right? So far, so good?
But let's zoom in a little closer, right into that nucleus. See, it's not just one solid blob. It's actually made of two different kinds of particles all stuck together. You've got your positively charged protons and your neutral neutrons. And for decades, that was the complete picture. Protons, neutrons, electrons. The end. But it turns out the story goes so much deeper.
All right, now this is where things get really interesting. It turns out that even the little guys inside the nucleus, the protons and neutrons, they aren't fundamental either. Nope, they have their own building blocks.
That's right. Protons and neutrons are actually made from a combination of even tinier, more basic particles called quarks. Specifically, they're built from two different types, and they have these kind of funny names, up quarks and down quarks. And these things are truly fundamental. As far as we know, you just can't break them down any further. This is bedrock.
And here's a really key rule about quarks. They are super social. You will literally never find a quark hanging out by itself. They are always bound together in groups, forming bigger particles like our friends the protons and neutrons. But you know how it is. For every rule, there's usually something that breaks it.
Because while quarks are busy building all the stuff inside the nucleus, there's a whole other family of fundamental particles out there playing by a different set of rules. So let's meet the second half of our story, the leptons.
So what's a lepton? Well, just like a quark, it's a fundamental particle, no smaller parts inside. But here's the crucial difference. Leptons don't get involved in the strong force. That's the cosmic glue that holds quarks together so tightly. And because leptons don't feel that force, they can exist all on their own.
So this is the big takeaway. Think of it like this. Quarks are the ones who can't go anywhere without their friends. They're always in a group. But leptons? They're the solo artists. They're totally happy to be on their own. And the most famous lepton of all? You already know it. It's the electron.
No way! That little electron we saw way back at the beginning, zipping around the atom, it wasn't made of quarks at all. It was a lepton this whole time. A solo artist, part of its own fundamental family, just hiding in plain sight. The electron's not the only one in its family, though. Oh no. It belongs to a small but really important group. It's time for a proper introduction.
Turns out there are exactly 6 flavors of leptons in the entire universe, and they're split neatly into 2 little groups. And here they are. On the left, you've got the 3 charged leptons. There is our old friend the electron, and then its 2 much heavier cousins, the muon and the tauon. Now for each of those, there's a matching neutral partner over on the right, the neutrinos. Each charged lepton has its own little ghostly neutrino counterpart.
And these neutrinos are just bizarre. They have almost zero mass, no charge at all, and they basically don't interact with anything. Seriously, right now, as you're listening to this, trillions of them are zipping right through your body, through the planet, without you feeling a single thing. They are the true ghosts of the particle world.
Okay, so we've got our quarks and we've got our leptons. You'd think that's the whole story, right? Nope. The universe has one more pretty huge twist for us. For every single particle we've just talked about, the universe also created a perfect mirror image. This mirror image is called an antiparticle. And the concept is actually super easy to get your head around. An antiparticle has the exact same mass as its particle twin, but it has the exact opposite electrical charge. That's it.
So for example, our electron has a negative charge. Its antiparticle, which is called a positron, is identical in every way. Same small mass, but it has a positive charge. It's a perfect mirror. And every single quark and lepton has a twin like this.
So, there you have it. When you zoom all the way down past everything you can imagine, all the regular matter in the universe is built from just these two fundamental families. You have the quarks, which huddle up to build protons and neutrons, and you have the leptons, like the electron, which flies solo.
These two families, quarks and leptons, they make up all the matter we've ever seen or touched. But here's the big question, isn't it? Is that really the complete story? Are there other forces we need to think about, other even more exotic particles we haven't met yet? Well, physics tells us yes.